Today's lesson will be just a review on the operations of adding, subtracting, multiplying, dividing in scientific notation. Before we begin this, I want to share with you a poster that is available with you, Operations with Scientific Notation. And I'm just going to open this up and we'll briefly go over these before we answer the 12 questions on the review. So operations in scientific notation. Always pay attention to which operation you're performing. So these are all color-coded. We notice we have adding, so you're going to look at what operations being asked to do. So we have adding, we have subtracting, multiplying, and we have dividing. So each one of these gives examples of the rules of what to do in answering your questions. So let's go through each one of these. Adding in scientific notation. First, if the numbers have different powers of 10, rewrite one of the numbers so that they have the same power of 10. So let's look at this. We have 8.45 times 10 to the negative fourth plus 3.7 times 10 to the negative third. We need to look at our exponents. We have a negative 4, negative 3. In this case, they're different. So we need to follow this rule. They're saying this step. If they have different powers of 10, which to rewrite one of the numbers so they have the same power of 10. All right, so in this case, let's make our negative 3 to be a negative 4. So to do that, what we are going to do, we need to change this set. The 3.7 times 10 to the negative third, we want to make it to a negative 4. So if remember Lars, L-A-R-S, so we need to subtract, because I want to get to negative 4, because negative 3 is bigger than negative 4, so I'm going to subtract 1. Since we're subtracting in Lars, L-A-R-S, we need to move our decimal one place to the right because of we are subtracting. So 3.7 now becomes 37. And when we move it to 37, our negative 3 becomes a negative 4. So we're now down to this step. We don't touch this one because it's already in correct form. It's at negative 4, negative 4. So we next have to add the coefficients. The coefficients are the numbers in front. So we're going to add 8.45 plus 37, and then we're going to keep the same power of 10. So if we add those together, we had 45.45, and we're going to keep the power of 10 of negative 4 times 10 to the negative fourth. Lastly, we need to make sure that the final answer is written correctly in scientific notation. So our answer is 45.45. This coefficient is too big. We have to remember our coefficient in front has to be between 1 and 10. And 45 is way too big. So I need to move my decimal one place to the left. And then in Lars, since we're going left, L-A, we need to add 1 because I moved it one place. So negative 4 plus 1 is negative 3. So our final answer is 4.54 times 10 to the negative third. If you're having questions on how to add in scientific notation, please contact your teacher. Subtracting in scientific notation. So we have 7.37 times 10 to the 10th minus 8.9 times 10 to the 9th. So first we need to look at our exponents. We have a positive 10 and a positive 9. It says first, if the numbers have different powers of 10, which they do, we need to rewrite one of the numbers so they have the same power of 10. So let's make this 10 to the 10th to be 10 to the 9th. So if we are subtracting one in L-A-R-S and Lars, S is subtract, and if we have to move, we're going to move to the right because R and S go together. For the acronym L-A-R-S, we need to move it one place to the right. So it's now become 73.7. And when we moved it to the right one, our exponent changes to the 9th, 10 to the 9th. And 8.9 times 10 to the 9th stays the same, being that it's already in. They have matching exponents. Next, we need to subtract our coefficients. Our coefficients are in front, so 73 0.7 minus 8.9, and we get 64.8. And we're going to keep the same power of 10. We add the power of 10 of 9. So times 10 to the 9th. Lastly, we need to make sure it's in correct scientific notation. If you remember, our coefficient in front has to be between 1 and 10. In this case, 64 is way too big, so I need to move my decimal place one place to the left, being we're going left in the acronym LARS. L is left. A is next for the acronym. A means add, so we have to add 1. So 9 plus 1 is 10. So our final answer would be 6.48 times 10 to the 10th. Multiplying in scientific notation. So we have 4.7 times 10 to the 6th times 2.9 times 10 to the 11th. First thing we need to do is multiply our two coefficients. So we're going to multiply 4.7 times 2.9. And when we do that, we get 13.63. Next, we need to multiply the powers of 10 by adding the exponents. So we have 10 to the 6th and 10 to the 11th. So we're going to add 6 plus 11, which is 17. So we have 10 to the 17th. Finally, we're going to put it together. So we have 13.63 times 10 to the 17th. We're going to make sure our final answer is written correctly in scientific notation. It isn't. This 13 is way too big. It has our coefficient in front has to be between 1 and 10. So I need to move my decimal one place to the left. In LARS, left, and A, L, and A go together. A is add, being that I just moved 1. We're going to add 1 to 17. So 17 plus 1 is 18. So our final answer is 1.363 times 10 to the 18th. And our last example is dealing with dividing. We have 1.55 times 10 to the 12th divided by 3.1 times 10 to the 7th. The very first thing that we need to do is divide our coefficients. That's the number in front. So 1.55 divided by 3.1 equals 0.5. Our next step is when we divide powers of 10 is we have to subtract our exponents. So we have our exponents of 12 and 7. So we're going to go 10 to the 12th divided by 10 to the 7th. We're going to subtract our exponents of 12 minus 7 is 5. So we have 10 to the 5th, and we're going to combine these. Now to make it into scientific notation, 0.5 times 10 to the 5th. Then we have to check to see if this is in correct scientific notation. It isn't. Our coefficient in front is a 0. We need to make this between 1 and 10. 0 is too small. So I need to move my decimal one place to the right. Now in LARS, L-A-R-S, R and S go together. R is right, S is subtract. Being I moved 1 to the right, we're going to subtract 1. 5 minus 1 is 4. So our final answer, after we moved our decimal 1 and we subtracted 1, we get 5.0, or just 5 times 10 to the 4th. So we want you to keep coming back to this sheet to help you with the review today as just friendly reminders as you go through. So on this example, question number 1 of our review for your work today. It says multiply. Write your answer in scientific notation. 5 times 10 to the negative 3rd times 1.3 times 10 to the 6th. So if we follow your order of operation chart, what you have to do for steps by step. So we're multiplying, so we're looking at this blue section. First we need to multiply your coefficients. 5 times 1.3. So so you can see what I'm doing. I'm going to bring up Desmos. And our review was 5 times 1.3. So 5 times 1.3 equals 6.5. 6.5. All right. And just glancing at this right now, This would be considered in correct scientific notation for the coefficient. Our coefficient in front, our number in front of the decimal, is between 1 and 10. So this 6.5 would be perfect. Now we look at filling in our blank 2, which is our exponent. And if we go back to our chart, what we need to do when we're multiplying powers of 10, we need to add our exponents. So let's go back and look. We're going to add negative 3 plus 6. And if you don't know that off the top of your head, use the calculator. So I'm going to clear this out. So negative 3 plus 6 equals positive 3. And so our exponent would be 3. And we look to make sure it's in scientific notation, the correct form, and it is. All right, let's move on down to number 2. Write your answer in scientific notation. Why don't you pause the video, try this one on your own, and then we'll go over it shortly. All right, let's go over our answer. So multiply, write your answer in scientific notation. We have 6 times 10 to the negative 4th multiplied by 4 times 10 to the 7th. So the very first step, if you remember, we have to multiply our coefficients. 6 times 4 is 24. I'm just going to put 24 right there. Now, this should be a red flag for you, meaning that this coefficient is going to be too big. If you wanted to put 24.0, you could, but our coefficient, our front number here, has to be between 1 and 10. So we're going to have to move our decimal eventually. So we'll wait until we're finished with that. The next step is taking our exponents and adding them. And if you need to go back to the poster to refer, so the first thing we did, we're multiply the coefficients. We did. Next is, if we're multiplying the powers of 10, we need to add our exponents. So if we go back, and we're looking at our exponents of negative 4 and 7. So if you need to go in to calculator, so negative 4 plus 7 is positive 3. Just as a reminder, when you're using decimals, you don't need to put equal sign. It'll automatically do it as you input your numbers. So our exponent is 3. The last thing that we need to look at is make sure this is in correct scientific notation. And just what I was referring to earlier, 24 is too big. I need to move my decimal one place to the left. So it's going to be 2.4. And I'm just going to write next to this so you can see what I'm doing. Lars. So being that I went, get rid of that. Being that I went from, the decimal was behind the 4, and I went left 1. So I'm looking at the L. So I want to show you what this acronym stands for again. Left, add, right, subtract. So we're going to look at, they go in pairs. So the L and A go together, or the R and S go together. So in this case, being that we went left, we're looking at just the L and the A. So we're looking at left, add. So that tells us we need to add to our exponent the number of places we moved our decimal. We moved it only one place. So we're going to add 3 plus 1, which is 4. So I'm just going to delete these. I just typed that so you can see what I was thinking. So our answer is 4. I'm going to get rid of the Lars. Should be 2.4 times 10 to the 4th. We're going to carry on with multiplying. One more example. So we're going to multiply 6.1 times 3.2. And we get 19.52. So I'm going to put 19.52. We should see that this coefficient is too big. We're going to have to eventually move. I'm going to put Lars to help us there. When I typed in the letters, I could automatically put a period or a decimal after it. So I just deleted it. But I will delete this acronym before we move on to the next question. I just keep it there as a reference for us. And then, as we did with the past two questions, we have to add our exponents. We have negative 6 plus -1. If you don't know what that is, use that Desmos. So let's clear this out. So -6 plus -1 is -7. There's our exponent, -7. All right, so now our last step is to look to see if this is all in the correct scientific notation, and it isn't. 19's too big. The coefficient in front has to be between 1 and 10. So I need to move my decimal one place to the left. And when we're moving left, we're using the add, so the L and the A. So I'm going to move my decimal in between the 1 and 9. I'm going to get rid of this decimal. And being that we moved one place to the left, we're going to add 1. So -7 plus 1 is -6. -6. We're getting closer to 0. So I'm going to put our answer as -6. And I'll delete Lars. So our final answer is 1.952 times 10 to the -6. And I believe that's all the multiplication questions. If you are getting hung up on the multiplications, please give an email to your teacher so they can set up a time to meet with you and help you along the way. Moving on to dividing, number 4. So we're looking at our purple section here on our poster. I'll read the question first, and then I'll have you pause the video. Write your answer in scientific notation. We're dividing. So we have 8.4 times 10 to the -4th divided by 2.1 times 10 to the -6. So since we're dividing, let's look at our sheet. It says first we need to divide our coefficients. So let's do that. We have 8.4 divided by 2.1. 8.4 divided by 2.1. And we get the whole number 4. There's our first blank. And that is a good thing. That means we don't have to move our decimal at all because our coefficient in front, 4 is just the same as 4.0, right? You could have 4.0 if you like, but no need to. You can just say 4. That coefficient has to be between 1 and 10, and 4 is between 1 and 10. Now we'll look at our poster. If we're dividing the powers of 10, we need to subtract our exponents. So we're going to go -4 minus -6. Now be careful, we're going to be subtracting a negative. And when we do that, they cancel each other out. So minus a negative would become plus plus. So -4 plus 6 would be +2, but I'll show you in a calculator on Desmos. Please feel free to use the Desmos. So it's -4 minus a -6, we get +2. So for our negative signs, we're just selecting the minus sign on this Desmos calculator. All right. So we look at our last step is making sure that this is in correct scientific notation, and it is. Perfect. Let's move on to the next one. All right. 6.8 times 10 to the 14th divided by 8.5 times 10 to the 10th. First step, we're going to divide our two coefficients. 6.8 divided by 8.5. 6.8 divided by 8.5. And we're going to get 0.8. Let's type it in. 0.8. Next thing, if we look at you can keep referring back. We are going to, being that we're dividing the powers of 10, we have to subtract our exponents. Keep referring back to that poster. That's going to help along the way. We're going to go 14 minus 10, which is 4. And up here, and our last step is to make sure that it is in correct scientific notation, and it is not. The 0 in front is too small. It has to be between 1 and 10, and this is too small. So we need to move our decimal. And which way are we going to move our decimal? So we're going to use our acronym LARS. And in this case, it's at 0.8. I need to move my decimal one place to the right. So it becomes 8, because 8 falls between 1 and 10. So I'm going to move my decimal there, get rid of those two. And being that we moved one place to the right, Now I'm looking at the acronym LARS. R is right, so I need R and S go together. So I need to subtract. Being we moved the decimal one place to the right, I need to subtract 1 from 4. 4 minus 1 is 3. So I'm going to delete those and put 3. I'm going to get rid of my LARS, and I don't need to have the decimal. I could keep the decimal there. I don't need to. So it's 8 times 10 to the third. It's the most cleaned up version. Okay, number 6. I want you to pause the video and try it. I want to read it first. 0.2875 times 10 to the 6th divided by 2.3 times 10 to the negative 9th. Pause the video and give it a try. Refer back to the poster. All right, you should have plenty of time to work through this one. So our very first step, we should notice that we are dividing. So what we need to do is take our number 0.2875 divided by 2.3. So I'm just going to copy that. I'm going to divide that by 2.3, clear this out. Divided by 2.3. And we're going to get 0.125. I want to copy this, and I don't think the decimal will carry over, but let's try it. 0.125. Oh, it did. Perfect. And then when we are dividing, we need to subtract our exponents, so use that calculator. 6 minus a negative 9, so you don't get goofed up on your decimals there. 6 minus negative 9. 6 minus a negative 9 equals positive 15. So if you're writing this out, you could say keep, change, flip. So this would become keep. We change this to addition, and we change this to its opposite, so it becomes a positive 9. So it's 6 plus 9 equals 15. So we have 15. All right, so the last step is reviewing to make sure that this is in correct scientific notation, and looking at the coefficient. The number in front, it has to be between 1 and 10. This number is too small. It's 0. So we need to move our decimal one place to the right. So I'm going to type in LARS. Oops. And being that we are going one place to the right, our decimal is going to go right here. I'm going to get rid of those. So we moved one place to the right, and since we're moving to the right, we need to subtract. We subtract by the number of places we moved, place value. So we moved it one place value. So we're going to subtract by 1. So 15 minus 1 is 14. And I'll get rid of LARS. So our final answer should be 1.25 times 10 to the 14th. All right, those are our 3 division problems. If you are still getting hung up on division questions, please contact your teacher. Moving on to addition, number 7. Write your answer in scientific notation. So we have 4.6 times 10 to the third plus 8.72 times 10 to the third. Let's look at our poster for addition. Addition is in the red here. And it says, the very first thing, first, if the numbers have different powers of 10, rewrite one of the numbers so that they have the same powers of 10. Well, let's look at our question. We have a power of 10 of 3 and a power of 10 of 3 here. So they have the same. So we can skip the first step. Then it says, add our exponents and keep the same power of 10. So we're going to add 4.6 plus 8.72. 4.6 plus 8.72. Yep. And our answer is 13.32. So I'm going to copy that. 13.32. And it says we have to keep our next rule says add the coefficients and then keep the same power of 10. And the power of 10 was 3. It's the same, so we keep it the same. And lastly is review our answer to make sure it's in scientific notation. And it is not. 13 is too big. It has to be between 1 and 10. So I need to move my place value one place to the left. So I'm going to put Lars. And being that we have to move one place to the left, we're looking at the L and the A. L and A go together. A stands for add. So our decimal is going to go between the 1 and 3. I'm going to delete this one. And being that we went left 1, we're going to add 1. 3 plus 1 is 4. I'm going to delete the Lars. So our final answer in correct scientific notation is 1.332 times 10 to the 4th. All right. So our next one, in question number 8, write your answer in scientific notation. We're adding 8.3 times 10 to the 6th plus 3.4 times 10 to the 5th. This one we should notice we have different exponents. We have a 6 and a 5. So when I want to make my exponent bigger, so if I want to match, I want to change this 3.4 times 10 to the 5th. I want to make this 5th to be a 6 to match. I want to add 1, thinking of Lars. Oops. If I want to add 1, I'm looking at moving my decimal to the left. Being we're adding 1, we have to move our place value only 1. So over here, it would be, this is what we're looking for. We're going to go 8.3. That stays the same. We're going to go plus. And being that we're moving our decimal one place to the left, I'm going to put 0.34. That will be the addition problem that we're going to be doing. And when I move that decimal place, we moved it one place to the left, we are going to be adding 1 to our exponent to make it 6. And I'll keep our exponent at 6. Okay, so let's add these together. Let's see if I can just copy and paste this into decimals. And we can. So 8.3 plus 0.34 is 8.64. I'm just going to copy that. And our last step is making sure that it is in correct scientific notation, and it is in this case. If you would have changed this exponent, the first set here, to a 5, you would have had, at the very end, you would have had to move your decimal. So there would have been a little bit of work, but you would have came out to be exactly the same. Same answer, just that you would have had one more step. So if you want to skip the last step of seeing if it's in correct scientific notation, make your exponents, match your exponents to the larger one. So we'd move this 5 to be the 6 because 6 is the biggest. All right, let's look at 9. If we wanted to go, we're looking at our exponents of 7 and 5. We want to change this 5 to match the 7. So here we go. We have 8.2 times 10 to the 7th plus 3.41 times 10 to the 5th. And tell you what, I'm going to move this 7 to our lower one. Just to show you we can get the same exact answer, just going to be an extra step. So our very first step, if we look at our poster for adding, if the numbers have different powers of 10, which they do, we need to rewrite one of the numbers so that they have the same powers of 10. So if I wanted to change this 7 to be a 5, I need to subtract 2 so that it would equal 5. So if we are looking at Lars, if we're subtracting, that means we need to move our decimal to the right because R and S go together. We're going to move it 2 places because we're subtracting by 2. The 2 and the 2, they go together. So we're going to move it over 2 places. So that would be 82, 820. So our very first number over here will be 820. It'll be now becomes times 10 to the 5th. We'd have matching exponents now. They're both going to be to the 5th power, and I'll put it down here to the 5th power. So now we're going to take 820, that's what we changed this to, so they can match to be the 5th, and I'm going to add it to 3.41. I don't need to change the 3.41 because the exponent of the 5 is already matching. So I'm going to copy this, 820 plus 3.41, and go into decimals, clear this out. I'm going to paste it, and we get 823.41. Copy that. All right, and our last step is to make sure that this is in correct scientific notation, and it is not. 823 should fall, this coefficient, the number in front of the decimal should be between 1 and 10. It's way too big. We need to move our decimal 2 places, because if we only moved it 1, we still have 82. 82 is too big. Now we need to move it 2 places, so it's going to be 8.23. So if we move our decimal 2 places to the left, it's going to be 8.2341. And I'm going to put Lars. And being that we move 2 places to the left, we're looking at left and add, L and the A. We move 2, so we have to add 2. So I'm going to plus 2. 5 plus 2 is 7. So put 7 here. I want to get rid of Lars and this. Whenever I want to go further, they just put a period thing at the end of a sentence. So our final answer is 8.2341 times 10 to the 7th. And this is in correct scientific notation. There's 3 examples of how to add using scientific notation. If you're getting hung up, please contact your teacher. In our last set of examples, we have the last 3 problems here, all dealing with subtraction. Subtract, write your answer in scientific notation. We have 7.8 times 10 to the negative 5th minus 4.5 times 10 to the negative 5th. So let's go to our trusty poster here. Now we're on the green one with subtracting. It says, first, the numbers have different powers of 10. Rewrite one of the numbers so that they have the same power of 10. In this case, let's take a look. They look at our powers of 10. Whoops, negative 5 and negative 5. They're the same. So we can skip that first step. Let's drop down. Next, subtract the coefficients and then keep the same power of 10. So we're going to subtract 7.8 minus 4.5. Our coefficients are the numbers in front. So I'm just going to copy that, and we're going to paste it into decimals. 7.8 minus 4.5, we get 3.3. So 3.3. Our blank 2, and with that rule, we go back. It says we need to subtract the coefficients, which you just did, and keep the same power of 10. And we're going to keep the same power of 10, being that they're matching. It's just going to be negative 5. Now let's look at our answer. We have 3.3 times 10 to the negative 5th. Look at our coefficient. Make sure it's between 1 and 10, and 3 is between 1 and 10. So this is incorrect scientific notation. Our next question, number 11, it's 3.5 times 10 to the negative 2nd minus 6.6 times 10 to the negative 3rd. I want you to pause the video, give this one a try. Please use the poster to help you along the way. All right, let's do these. So the very first step. First, if the numbers have different powers of 10, rewrite one of the numbers so they have the same power of 10. So let's do it. So we have a -2 and a -3. They have different powers of 10. We want them to be the same. So what I want to do is I'm going to pick moving my exponent, or changing the exponent to match the larger exponent. So when we're looking at two negatives, the larger exponent is going to be the one that's closest to 0. So a -2 is closer to 0 than -3. So -3 is smaller. So I want to change this -3 to match this -2. To get -3 to equal -2, I need to add 1. So if we're looking at Lars, when we're adding, we're looking at L and A. So we're only looking at this set, 6.6 times 10 to the -3. We are going to be keeping our negative exponent, exponent of -2. That's what we're matching. And being that we are adding 1, because -3 plus 1 is -2, we have to go left 1. So right now it's at 6.6. When we add decimal one place to the left, it's now going to become 0.66. Oops. 0.66 times 10 to the -2. All right, our last step is making sure that this is in correct scientific notation, and it is not. The 0 in front of our decimal is too small. It has to be between 1 and 10. So I need to move my decimal one place to the right. So putting in Lars, if we're going one place to the right, we need to subtract. The R and S go together. We're going to go -2. We're moving it only one place. We're going to subtract 1. -2 minus 1 is -3. We'll put -3. And we're moving it one place to the right, so I'm going to get rid of this 0 point. I'll move my decimal. So it's going to be 6.6. Get rid of my Lars. Now we make sure this is in correct form now. 6.6 times 10 to the -3. That is in correct form. All right, looking at our next one. We have 4.8 times 10 to the 5th minus 7.3 times 10 to the 3rd. Our very first step is we're going to try matching our exponents. We have different exponents, so we need to move our decimal. I want to change this 10 to the 3rd to be 10 to the 5th. I want to match it to be the bigger one. So if I want this to get to 5, I need to add 2. So if I type in Lars, being that we're adding, we need to move left. Being that we're adding 2, we have to move 2. So we're moving 2 places to the left. So if we move our decimal 1, 2, so it's going to be 0.073. Okay. Now what we're going to do is we're going to subtract 4.8 minus 0.073, because now we're going to have the same exponent of 5. Put that down in blank 2. So I'm going to put in 4.8 minus 0.073. I'm going to copy that, put it in decimals, and we get 4.727. Copy that. I'm going to paste it there. And lastly, we review our answer to make sure it is in correct scientific notation. 4.727. Looking at our coefficient, 4 is in between 1 and 10, so that works. And our exponent is not a fraction. We know that works. So this is in correct scientific notation. So any of these 12 questions that we went over today, if you're getting hung up on any of them, please contact your teacher. Your assessment next week will be just like these questions. All right, have a good day.